Okay, so let's talk about some reactions that alkenes do, and I'm just going to introduce um, a reaction tonight in preparation for class. So, first of all, alkenes are generally nucleophiles, and these are some of the reactions that are possible. You can convert an alkene into a dihalide. You can convert an alkene into an alkyl halide. You can convert an alkene into an alcohol or a diol. Just depends on the conditions. To a cyclopropane. You can convert it into an epoxide, or you can even take the alkene and convert it into a carbonyl. All right. Normally, when we look at these reactions and the products, and we get kind of freaked out, but just think about the alkene being dressing up as different things, and the reagents that make the alkene or convert the alkene into these other products are like makeup, right? So the alkene can put on a particular type of makeup and change itself into or become one of these products depending on the conditions. So we'll talk more about that in each one of these reactions. For this video, we're going to focus on converting the alkene into a dihalide. Right, so before we do that, we need to talk quickly about how to make alkenes. Most of the times, alkenes are derived from elimination reactions, either from alkyl halides, where you eliminate H and Cl to put a double bond here in the product, or from elimination of water by acid catalyzed dehydration. So, right, in this particular case, KOH removes this H, and it starts basically a elimination process where these electrons come here to make my double bond, and then the chlorine leaves. All right, in the bottom reaction, here's the mechanism of how that happens, where first the OH is protonated, it becomes water, and then the chlorine here comes back and deprotonates this site, pushing these electrons. Here to give you the double bond, and then you lose water as a result. So this is what's called a dehydration. Anytime you lose water, that's considered a dehydration. The top reaction is what we call a dehydrohalogenation. That's a big word, but all it means is that I'm losing hydrogen and a halogen from the alkane or the alkyl halide to give me the alkene. All right. So the first reaction that we're going to look at is addition of X2, X being any halogen with the exception of fluorine, across a double bond. All right. So this reaction always, this is something that you can write down in book, it always occurs with anti-stereochemistry. What that means is that the two bromines never add to the same side. They always add to the opposite side. All right. And the reaction proceeds through what we call a bromonium ion intermediate. All right. So notice I have a double bond. Again, this is an addition. So I have two things, I add them together, and I get one product. So both of these bromines add across this double bond. So let's look at the mechanism. All right. So here's the mechanism, and I'm going to skip to the next slide because the mechanism, I have it animated on the next slide. So here is my double bond. It's acting as a nucleophile, right? So the double bond attacks bromine here, causes the bromine-bromine bond to break, and I end up here where this is a carbocation because I broke the double bond. However, it doesn't stay that way. Bromine actually attacks the carbocation and gives me what we call a bromonium ion intermediate. This intermediate is common to every halogenation reaction. All right, so now this is intermediate can get converted into the product, which is here, right? And before we go from here to the product, this happens really fast. So once this double bond breaks, this step is basically instantaneous in the formation of this bromonium ion intermediate. So now, if you recall, we lost a bromine over here. That bromine comes in, and now it can attack here. This is the hallmark of this reaction. The second bromine that comes in has to come from the opposite side of where the first bromine already is. So if this is here on the underside of this ring, the other bromine that comes in has to come in opposite of that. And so now let's look at what happens. Here are my arrows where this bromine donates a pair of electrons here, and now I form a new bond between carbon and bromine, and I break the carbon bromine bond here. Let's look at that again. All right, so now here's my bromine coming in, right? Watch the arrows. I'm pushing here and I'm breaking this bond here. And then I form a new bond between bromine and carbon here, and I break the carbon bromine bond here to give me my product. A second reaction that involves bromine and a double bond is here, where we have a similar alkene, or the same alkene, and we treat this with bromine, but we do the reaction in water. All right, this is called a Halohydrin formation, right? OH here is the hydrogen part, and here is the halo part, so Halohydrin, right? Again, this occurs also with trans or anti-stereochemistry, where Br and OH are never on the same side. So let's look at what happens here. So again, the first part of this mechanism is identical to what we just saw, where the double bond attacks bromine and you lose bromine. All right, so then you here again, that collapses and you form the bromonium ion intermediate. The difference for this reaction is that instead of bromine coming in to attack, water does. All right, so water attacks, same arrows, right? Now I have a bond between oxygen and carbon, and I broke a carbon bromine bond. That gives me this hydronium intermediate, and then now I need to go from here to the product. So then the bromine simply comes in, deprotonates water, and then I have my product plus HBr. Let's look at that again. All right, so here comes water coming in. It attacks. All right, I get a new bond here between carbon and oxygen. I break the bond between carbon and bromine, and now I'm at this hydronium intermediate, and now bromine comes in and deprotonates that, and then I get my product shown here, my halohydrin. So we'll talk more about this reaction in class. As always, if you have any questions, you can tweet, you can email, or you can drop by my office. Peace.